Ladies and gentlemen, my name is Gordon Chakaodza, and I'm delighted to facilitate the next session on hydrogen, particularly focusing on hydrogen mobility. It's very hard to go past a day without hydrogen being in the news, certainly here in Australia. So there's certainly a lot of activity that is taking place, and hydrogen is certainly a promising fuel that will help to decarbonize our world. And certainly in Australia, we're seeing many projects such as that are looking to use hydrogen to decarbonize our heavy industries such as steel, hydrogen in mobility applications, both passenger and vehicles, the potential use of hydrogen to fuel our aviation sector, and also, projects such as looking at blending hydrogen into our gas systems. So very exciting opportunities for hydrogen. And we're delighted today to have 4 fantastic speakers who are all involved in aspects of the hydrogen value chain. So I might invite our speakers to come up to the front, because we are going to we're going to approach this session in an interactive way. So while the speakers are making their way to the front here, I will just give you a brief background about them. Their full background is in the program, but we have Professor Francois Aguey, who is a professor of chemistry at the University of Sydney, and he's also one of our leading experts in hydrogen technologies, advising many stakeholders. Associate Professor Mahnaz Shafiei is at Swinburne University and is currently Vice-Chancellor, the Vice-Chancellor's Research Fellow and Women in STEM, and she has extensive experience in nanomaterials, gas sensing techniques, and device fabrication. We have Prune, Bokobza, hope I say that correctly, who is an international expert in hydrogen and renewable energy at Expertise France. And also Niels, Leemput, who is technical manager at Engie Impact. And Niels is managing a number of projects for Engie in the Asia Pacific. So quite a diverse panel, and I'm very much looking forward to hearing from the panel. So the way we'll approach this is that each of the panel members will say some opening remarks in the form of a short presentation, and then we'll move to a facilitated panel session, and then you as the audience will be able to ask the panel members any questions that you might have. But to kick off, you heard earlier this morning when Pascal talked about the Victorian Hydrogen Hub. So I might just talk about that in a few moments, just to give you context of what the hub is. So VH2 was funded by the Victorian government last year in 2021, and we received $10 million to kick off VH2. We've used that funding in 2 main parts. Firstly, demonstration projects. So one of our key demonstration projects is constructing a refueler in partnership with CSIRO, and we expect that refueler to be in place at the beginning of next year. We're also doing some work around hydrogen tanks and storage with our partners in Germany. So hydrogen tanks is going to be particularly a key research area for the hydrogen economy to become a reality. So we're delighted to be partnering with the University of Stuttgart on those hydrogen tanks. And we're very much looking forward to some of those results that will start to come out in 2023. We're doing a lot of work on skills as well. So while the companies like Engie looking at various projects, the people who are going to maintain those projects is going to be really critical. So we've just completed a piece of work to actually identify the gaps of what skill sets are at the moment, and importantly, what qualifications will be needed to support a future hydrogen economy. So that work has been a critical piece of research, and from that, we're now actually starting to develop short courses to support the future industry. The community and social license is a key important. So it's really important to bring the community along in terms of the hydrogen development projects, particularly in Australia. So we've done a lot of work over the last 12 months, working directly with the community to help them educate, the potential benefits for hydrogen, and also educate some of the challenges as well. As part of that funding, we've also funded a number of PhD and master's projects. So our PhD candidates are working directly with industry on some of those things I mentioned, decarbonizing steel and decarbonizing the aviation sector, just to name a few. I think one of the unique things about the VH2 program is that it is industry-based. So the research questions which we're working on are coming directly from industry. So this slide here gives you a sense of some of the companies that we're working with. You can see companies like Ampol, companies of BOC. So whether it is our PhD projects or some of our industry projects which are taking place, these are really having impactful outcomes for industry. So it's something that we're particularly proud of. So I thought I'll just take a few minutes just to give you a bit of context on VH2, because you heard about it this morning, but I'm certainly happy to take any questions later on in the presentation. So with that ado, I might invite Francois to come up and provide an overview. Thanks, Francois.
Thank you, Gordon. Yeah, that's little bit. So this works. Oh, perfect. Okay, so what I'm going to try to do is give you a little overview of Australian hydrogen vision and where we are at today. The Australian hydrogen strategy was put together in 2019, and this was one of the first in the world, with the ambition that Australia has plenty of renewable energy resources, and this could be exported in the form of hydrogen. Why hydrogen? Because it has a high energy density compared to any other fuel, and it's clean, assuming that it's produced from renewable energy and water as a feedstock, and you produce as a byproduct water. So in theory, it's clean, but it really depends on how it's done. The reason Australia is looking at hydrogen also is that there is a high level of solar radiation in Australia, one of the highest across the world. Other countries in South America have similar level of radiation. And so we have also plenty of space in this country, although it's indigenous land, where potential large-scale renewable farm could be installed. So that's the level of investment today across the planet. So it's billions of dollars that are invested. And you see typically on that map where the investment is made, mainly in Europe. And there is a reason for that. There is no oil and gas anymore in Europe, without talking about Russia. In Australia, because of that potential of renewable energy, and South America and North America, simply to keep North America is to try to keep competitive advantages. And obviously you have countries like Japan and South Korea pushing also very hard. So in Australia, you may have seen this map before that CSIRO has been asked to put together, also the range of research projects, but these are research projects by individual, because as we know, research is not well coordinated in this country. And so, but you have a range of already industry projects that are different at different level, from pilot scale project to large scale, like Asian Renewable, where they are planning to produce million tons of ammonia to export. In terms of R&D priorities, these are the R&D priorities that have been identified through an exercise done by CSIRO. So typically in Australia, what we are looking at obviously is how can we better produce hydrogen at scale and cheaply, how we can transport this hydrogen, and how we can use it for heavy-duty mobility, because as you know, Australia is a big country. You need to be able to run those heavy-duty trucks, for example, or train and decarbonize them. I will not go into that, but this is more or less a similar information of where the low-hanging fruit of hydrogen could be. So this is an exercise that has been done by the Net Zero Australia Consortium, involving a few universities in Australia. And they have been brave because, as you probably have heard, all the states are competing with each other, and there is nobody from the states here. Okay, so I can say that. To be able to produce hydrogen at scale. And what they have done is typically replicate what everybody would imagine, that if you export to Asia, you would want to implement those large-scale renewable plants in the north of Australia. So, for example, you are not going to do that in Tasmania, it's too small. You are not necessarily going to do that in Victoria, it's too far. So you want to put those plants in the north. And what you can see is that those plants are big projects, very large-scale projects. And so where the investment comes from that, how those projects are going to be deployed remain a high-level question. Okay, I should stop here. Thank you.
Thank you, Francois. Our next speaker is Prune.
So, hello everyone. Thank you, Gordon, for the introduction, and thank you for the organizing team to have me today. I'm very glad to be joining the AFRAN Forum this year. For us, hydrogen is at the heart of the energy transition. France is convinced that decarbonized hydrogen will be one of the great revolutions of our century. It is a key for the decarbonization of the industrial sector, for developing and deploying emission-free mobility solutions, as well as energy storage, and of course, addressing the intermittent nature of renewable energies. So first, I will briefly introduce some of the key figures of France's cleaner hydrogen plan, our main objectives and projects in France. Then I wish to share with you a bit more about France's expertise on the mobility sector and the current stage of French-Australian cooperation. So not getting into the details because a lot of my colleagues have spoken about the France national strategy toward the low carbon technology development. But just to remind you of our main objective is to reduce the emissions of CO2 by 81% by 2015 compared to 2015. And then we also have a second big objective is to raise the part of the renewables energy in our energy mix by to achieve 40% by 2030. And we think that hydrogen is one key to achieve these great ambitions. So we are aiming of having a capacity of 6.5 gigawatts of hydrogen by 2030. And this capacity should save around 6 megatons of CO2 emission. And just to give you a reference point, this is actually the equivalent of the annual emission of the city of Paris. And this core objective is enacted into the French law, and we have an objective of 20 to 40% of total hydrogen consumption sourced from low carbon and renewable hydrogen by 2030. With the first stage at the end of next year that is of 10%. So focusing a bit more on mobility, we also have an objective regarding refueling station. And this objective is to have 100 charging stations by the end of 2023, so next year, and to raise them up to 1,000 by 2030. We are already on our way to achieve this goal because we currently have 61 operating refueling stations across France. To support this very ambitious strategy, France will invest 9 billion euros by 2030, and we have set 3 priorities to this investment. So first one is installing enough electrolyzer to make a significant contribution to the decarbonization of the economy. So among the various processes that we could choose, the strategy of France was electrolyzers because it appears the most promising, and we do have a long-term acquired expertise on this technology. And just recently, if I can give one example, The French company McPhy has taken the final investment decision to construct the first gigafactories in Belfort of electrolyzer in France, and is aiming at producing 1 gigawatt of hydrogen. Then the second objective is developing clean mobility, especially for heavy-duty vehicles, because of course it's the most difficult part to decarbonize, and hydrogen appears to be one of the promising solutions. We'll have a first phase of conversion of land transportation of passenger and freights to hydrogen technology, which means light and heavy trucks, buses, as well as trains. And then in parallel, we are developing key technologies and components to have the first pilot project around river shuttles, ships, and well, maybe we hope one day plane. And I'm very glad to share with you current news from last fall, if we see it on a European perspective, or the spring of Australian perspective, so around November this year. The French transport company Alstom has just be able to make their first hydrogen powered train happen. It's in Germany, and they're operating a bit more than 10 trains. So this is a world's first, and we are very proud to have a French company that has made this train possible. Then the third priority is to support R&D. To develop more efficient technologies for all use of hydrogen, which also mean supporting business startups and industrialization, combining a European approach and a national approach. And just one example I can give you is the development of the joint venture called Engie in France that is aiming to develop a new solution for electrolyzer by targeting high temperature electrolyzers. So this whole 9 billion package will support French established expertise on the whole value chain of new technologies, from this electrolyzer gigafactories that is making, that will be possible because of our long-term acquired knowledge from research centers such as CEA and CNRS, to the international presence of French companies that are already well established on the Australian market, such as Neo and Engie, Air Total Energy, and those on the development of the transport fueled by green hydrogen with, for example, Airbus, Alstom, Transdair, on the French-Australian JV Keolis donor. We are seeking to be more connected to Australia to achieve our ambition. Australia has a substantial amount of natural resources, a strong expertise, and ambitious policies from the states. And for us, Australia stands out as a leading actor in the clean energy sector. And we already have a lot of project and cooperation to scale up these technologies. So regarding the R&D cooperation, I want to mention the great collaboration between 5 Australian universities and 8 French laboratories within the RNS passes, which is a collaborative French-Australian research network on energy materials, integrated system for electrochemical storage and hydrogen energy. But if you have a question, I'm sure Francois will be the one to be asked. Our French researchers in Australia are very keen to develop new exchange opportunities. Actually, I was speaking yesterday with a French researcher who is in Sydney and was wanting to develop a new fuel cell focus group. So if you have any interest, don't hesitate to let us know. And we also have a very dynamic French tech community in Australia, trying to build more link between the two innovation ecosystem. On the industrial field, French companies are already part of innovative projects. Well, I'm sure you all heard about the URI project led by Engie in WA. It was big on the news last September. So Engie has just started a demonstration scale renewable hydrogen and renewable ammonia production and export facility, including an electrolyzer of 10 megawatt. But for this project, I'm sure Niels will be the one that will be giving you more information. Well, back to mobility. I'm glad to share with you that the French gas company Air Liquide is partnering with Viva Energy to build the first refueling station in Geelong. And Air Liquide will be providing a fast-fill hydrogen refueling package designed to refuel at least 10 trucks or buses consecutively. So this leading-edge system will be the largest in Australia and will be capable of dispensing 300 kilograms of hydrogen in under 2 hours, which aims to match the speed of a traditional refueling station. In Queensland, we have the French bus company Transdev, who's investing to cover the procurement of 2 new hydrogen buses, as well as the necessary hydrogen supply infrastructure. And this is one of the first H2 bus projects for Australia. And then lastly, I want to mention the work of the joint venture Keolis Donner. So Keolis Donner is taking part of a big consortium to develop green mobility at the Newcastle port, along with the hydrogen hub in New South Wales. I know there are many other opportunities for partnership between France and Australia company and university. And well, I'm at your disposal to answer any question. Thank you.
Thank you, Prune. I'm sure you'll have many questions at the Q&A session. So we've got Mahnaz, thanks. Our next speaker is Associate Professor Mahnaz, who's going to talk about a research, particularly focusing on hydrogen safety.
Thanks, Gordon. And I would like to thank the organizer for this, for the invitation. Good afternoon, everyone. So in this short presentation, I will do an overview of safety aspects of hydrogen using nanomaterials-based gas sensors. Sorry. Okay. With increasing concerns with global warming, security, pollution, safety, the demand for reliable, highly sensitive, and selective gas sensors are increasing. So the gas sensors are devices that we can use to detect different gases in the presence of other gases. And we can measure the concentration of these analyte gases in the range of part per billions. And these gas sensors can be used widely in many different applications, which we can see in this figure. Some of the applications, for example, can be used as a breath analyzer to detect biomarker of some diseases. They can be used for air quality monitoring. And also one application of the sensor, the gas sensors, is the hydrogen industry. Okay, so we heard from Gordon and other colleagues regarding the hydrogen as a renewable energy. So hydrogen is a clean and efficient and promising candidates to be used as a renewable energy sources. As we can see in this plot, yeah. As you can see in this plot by Australian National Hydrogen Strategy, the demand for hydrogen use is going to increase significantly over 3 decades up to 2050. And we see some potential uses for hydrogen, for example, as we heard about in the other presentation. So one could be transport, mobility, can be used as a heat source. They can be exported. They can be used in chemical industry as a fertilizer, and also can be used for grid electricity. However, there are some concerns with hydrogen because the hydrogen is very flammable and explosive with the concentration above 4%. So we need to make sure the safety aspects in each step of hydrogen during production, storage, transport, and uses. So for this reason, we develop gas sensors. Here I have listed demands and requirements for an ideal hydrogen gas sensors. So some of the parameters which I can mention here, for example, is the range of concentration the sensor can detect. It depends on the application. So we need to have reliable sensors so the environmental parameters cannot impact on their sensing performance. For example, humidity, temperature, or pressure. So the lifetime is important, the cost, the size. Also, one more important parameters we need to consider for ideal hydrogen sensor is the low cross sensitivity with other gases, and they need to be fast in terms of the response time and also recovery time. So we have done survey of the commercial hydrogen sensors available in the market. So they are using different technology, which I didn't bring here because of the time, but each technology has their own advantages and disadvantages. So still ongoing research is required to improve the sensing performance of these sensors to meet demands for hydrogen economy. So we need to still improve the sensitivity, selectivity, so to reduce the cost, the power consumption, and also the size of these sensors for different applications. So here in this slide, I'm just highlighting the role of nanotechnology in sensing technology. So we are using nanomaterials as a sensing layer because of their unique properties. For example, large surface to volume ratio, they have more surface active sites. They are not very expensive. They can be integrated to flexible devices. So using nanomaterials as an active layer, so we can enhance the sensing performance. Here you can see one figure is missing anyway. So some images of some nanomaterials we have developed in our group for sensing. And here I'm showing the capability as Swinburne. So we have the capability to synthesize the nanomaterial, to characterize them, to fabricate this device. And also we have a sensing system to test them under different operational conditions. And also we have the capability of development of portable systems, so we can bring these developed sensors in the lab to the real environment for real application. And here just introducing two other hydrogen research activities at Swinburne. So we are involved in ARENA project funded by ARENA and also industry partners, which is led by QT, our collaborator. So we have built a hydrogen pilot plant in Redlands in Queensland, and which is 100% renewable hydrogen for export. And we are looking at Swinburne, we mainly looking at safety aspect, development of hydrogen sensors. The other project, which is funded by Phoenix CRC, Future Energy Exports, and also industry partners. So we are developing, in this project, we are developing cyber physical system to enhance the efficiency and safety of the hydrogen plant. And also in this project, we are building a lab scale hydrogen plant at Swinburne as well. And here I've just listed some ideas for collaboration with French researchers. So at Swinburne, we have the capability of developing materials, promising materials for sensing. We have capability to develop the devices and test them, and also design and development of portable system platform for different applications. And through the recent delegation trip to France, so I want to highlight that we can collaborate with French researchers on safety aspects of hydrogen, because they have the facilities for prototyping, and also we can collaborate on certification, regulation, and also standards. And at the end, I would like to acknowledge my collaborators, PhD students and postdocs here in Australia and overseas, and also the funding agency to support the research we are doing. And thank you so much for your attention.
Thank you very much, Mahnaz. So our next speaker is Niels Leemput, who's from Engie Impact, and he's going to tell us about what Engie is doing in the Asia Pacific.
Thank you very much. Thanks for the opportunity to speak here. I'm going to be very short about this. So I'm part of Engie Impact, which is the advisory branch of Engie. Let's check there. Maybe. So we assist organizations in their decarbonization journey, meaning corporations such as Yara, which was mentioned, where we are collaborating with them to supply them with green hydrogen for the production of ammonia, which is used as a fertilizer and as a material for explosives in the mining sector. I've been working on that project, so it's indeed the first step there with a very important first step project with a 10 megawatt electrolyzer that is fed 100% by renewable energy from a solar plant combined with battery storage, as it is an off-grid application. The whole plant is off-grid at the Burra Peninsula in the Pilbara. This was funded by ARENA partially, so we were very pleased with that support. And we're looking at the next stages of this project to scale this up from the 10 megawatts towards 2030 to plus 1 gigawatts to fully supply that plant with renewable energy. So plenty of work ahead. As was mentioned already, for Engie, the development of hydrogen, green hydrogen, is extremely important. So we've got, I think it's 25 projects being in development. And one of our flagship projects is, of course, the Yara project in the Pilbara, but there's also the Murray Valley project, where there's gas grid injection with renewable hydrogen together with AGRG. Now, why is this important? Why are we so interested in hydrogen? Well, we're so interested in hydrogen because we need to decarbonize. Everybody knows that. I'm not going to repeat that because many people have told this, but there's also some sectors are very difficult to decarbonize directly by electrification. So we are not a big fan of sometimes the debate about whether it should be electric or hydrogen. We need to decarbonize, period. And we need to find the best application for each of the opportunities there. So electrification makes a lot of sense in a lot of applications, but there are applications where direct electrification is very difficult. So we need to focus on those so-called hard-to-abate sectors and see what we can do there. Within that, there's an important part on industry, of course, but also a very important part on transport. And when we talk about transport, we're not just talking about cars, we're more talking about the more difficult sectors in transport, heavy duty, long distance, where weight, payloads, uptime makes it very important, and where batteries physically would not meet the needs for that one. So we do know that a direct electric approach in principle is more efficient. So cars in Australia, so a country where there's plenty of renewable energy for passenger vehicles, probably the bulk of the cars can go electric with batteries. 500-kilometer range and more are in the pipeline. The recharging infrastructure is being built. However, the range per kilogram of weight of your system, that becomes critical in trucking, which is very important in Australia, given the distances and the remoteness, shipping, aviation, and so forth. So it's important to look at which application and what is the best suited technology there. So we say, let's look at the right applications. The train of Alstom has been mentioned. There's a few driving around in Europe. We've got, of course, buses, mining trucks, very relevant application in Australia. Engie is working in South Africa on a hydrogen mining truck. There's a lot of interest, obviously, on the mining sector in Australia as well. Aviation in the long run, where, of course, Airbus is working on this very actively together with some other French companies. There were a bunch of examples. I don't want to go into that now, but as you receive the slides, you can see at some of these comparisons on why it makes sense to go in that direction, because there's a lot going on there. What I just want to focus in the opportunities for Australia. So, sorry, Engie's vision is that we have regions with an energy surplus, and we will have regions with a renewable energy deficit. Those energy surplus regions include Australia, South America, North Africa. In those regions, we want to develop hydrogen production and some applications at scale to then have that scale and that cost reduction to export to energy deficit regions. If you look at this globally, the way we see it is there are some zones, and this is very high level, where are surplus and deficit regions, and you can almost link them to where you see hydrogen projects being developed. So Australia is squarely the surplus region for Asia Pacific. There's a lot of energy demand in this region and a lot of energy deficit countries such as Japan, Singapore, South Korea that physically don't have the space to put the renewable energy installations they would need. On top of that, Australia has some benefits compared to some other regions in terms of the stability of the regulatory framework. This is extremely important for this type of investments. And this is a challenge, for example, in South America or even in North Africa. And of course, the workforce, the skilled labor and the productivity of the workforce. So what we mean by that is there's plenty of empirical evidence in Australia from the oil and gas sector, actually, of the ability of the Australian workforce to develop these kind of industries at scale in a rather short time frame. So there's a huge opportunity for that workforce that is now working in fossil fuels to find a way to get them into the renewables and to have a substitute for energy exports that is green, because as everybody knows, it makes up a big part of the Australian economy and the trade balance of Australia. So connecting those regions is important. For connecting them, there's different options of how to carry hydrogen, because hydrogen is a gas, but it's a very low density gas with a lot of challenges. So what we are also looking at with our colleagues in our labs is what are the best ways to carry hydrogen over long distances as safely as possible and as efficient. There's different carriers or different methods such as liquefaction, making green ammonia, using organic carriers and so forth. The key message there is that for this value change, there's not one size fits all. Just like today, we don't use one hydrocarbon, we use diesel, gasoline, propane, whatever. There will be multiple kind of carriers, and Australia is already developing at the R&D and pilot stage many of those. So there's some liquid hydrogen pilots, there's obviously our ammonia pilot, which is being built and so forth. So the key takeaway there is also there's not one size fits all. There will be different carriers for different applications and different regions. And we're looking at most of them ourselves. I'm going to stop here and thank you for your time.
Thank you very much, Niels, for that really informative presentation. We were going to have a facilitated discussion, but I'm seeing that we quite pressed for time. So what I want to do is just invite the audience to ask some questions. And if we've got time at the end, we'll do a facilitated question here.
Thank you, Jean-Paul from CNRS. Just one question to our colleague from Engie. Do you implement R&D in Australia?
So that's a good question. So Engie has, I think, about 15 or 20 R&D labs all over the world. There's a big one also in Singapore focusing on hydrogen. So for Australia, there's a close collaboration with that lab. Besides that, Engie has some collaboration agreements with another university in Victoria, with Monash University, where there is a joint R&D, and Engie is very open to that. Of course, always considering topics that are within our field of interest and where we see that long-term, large-scale application. But in that field, yes.
Hi, Christoph Rüdiger, Bureau of Meteorology. This morning we heard Gilbert Brunet talking about the water cycle. And of course, hydrogen, you convert that into water vapor, essentially down the road. Has anybody ever done a projection as to how much water you'll actually be pumping into the atmosphere? Because that will have an effect potentially on our, especially local weather. I mean, if we're going to model urban weather at 100-meter resolution and we have a lot of cars running around here blowing out water, or the local energy production being hydrogen-based, has that ever been considered as a 2050, 2100 vision?
So very good question. I've been asking myself that question for a long time. So if you can help me to answer, that would be great. What is the effect of water emission on the water cycle? That's a question that nobody is asking, and I think nobody wants to know. What is the impact of hydrogen on the greenhouse and the climate? Because when you talk about large projects like this, there will be hydrogen emission. What is the global impact of that? I think there are some publications already that start to say that hydrogen can interact in the higher atmosphere and generate some radicals and so forth. But all those things, I think, needs to be verified with actual experiments. So we have a better understanding of, I'm going to say something bad here, as another, if hydrogen is really a good idea. But I think beyond that is, as we transition to new energy system, is actually how we learn from the mistake we have done in the past, and we try to do better. No system is perfect, right? There will be always some downside. So the question we should be asking ourselves now is, what are the downside of hydrogen and how we can do better? Then if there is enough water around, yes, there is plenty of water in Australia. The problem is not if there is enough water around, the problem is how this water is managed. So for example, if you look at the way water is managed in Australia at the moment, the Bureau of Statistics doesn't record water used for energy production. And obviously, if we start to produce hydrogen at scale in Australia from water resources, this will have to become an imperative, just from a social license perspective to start with.
I think it's a very important question, especially making sure the water is used as efficient as possible. So in a lot of these projects, especially in Australia, but it's similar in Chile, the water that is used for hydrogen needs to come from desalination because there is no source of water. And we try to close the loop. So the water that's exhausted will be condensed again to minimize the uptake. And I think it's important to look at this in perspective to the alternatives. So if you have a thermal power plant, like a coal power plant, the volumes of water going in the atmosphere for cooling are different orders of magnitudes because you cool away 2/3 of your thermal energy. Similar in Australia, the water use of the mining sector, we run many of those assessments, like the additional water use to go to hydrogen is less than 1% of what they use for tailings, which also evaporate in the end of the day at a slower pace, but they evaporate. So it's a very important topic, and I think it's an important topic for all industries that are big water consumers, which sometimes go under the radar in this kind of discussion.
Hi, Romain Ragonnet from Monash University. Yeah, thank you for these presentations. They are very interesting, and I think hydrogen is very exciting. And that makes me quite optimistic about the ability of replacing carbon-based energies. But I'm also wondering, a few decades ago, people might have been similarly excited about other renewable sources like wind-based energy or wave-based energy, which are also relevant, highly relevant to Australia. I guess we have plenty of waves and wind. But still, we haven't succeeded. There's still a lot of carbon-based energy around. Would you be able to provide some perspective, just comparing very briefly what's new, what's very different about hydrogen? Why would this work and why the other solutions did not work that well? Just to make me even more optimistic.
Thanks for the question. I can start. The answer is pretty simple. We don't have the choice. So typically, if you look at the target of decarbonizing, and everybody talk about net zero by 2050, what this means is in reality is that the lifetime we have now, which is about 12 kilograms of CO2 per individual per year, we need to go down to 2 kilograms. How do we do that? The answer is pretty simple. We need to find other sources of energies to be able to do that. So we don't have the choice. Where this energy is coming from to sustain the lifestyle we have? Probably it's hydrogen or renewable energy. And on top of that, we don't even talk about the environmental footprint of all those systems.
If I may add, one key difference is that hydrogen as such is not a source of energy, so it's a carrier. It might actually enable some of those other technologies like wave power and so on, because they, by combining solar, wind and others, you can have a more consistent profile of renewable energy going into those electrolyzers. I think we also have to acknowledge there's a potential risk with hydrogen because it's a carrier that can also be made from fossil fuels to make sure there's enough scrutiny on the source. So the whole, blue and all colors that are being mentioned, there's a certain awareness to make sure that we are not end up with a less efficient system running on fossil fuels. For Engie, it means we only do green hydrogen. We are not involved in any gray one. I think we are also looking at what is called pink hydrogen in France. So combining it with nuclear power generation due to the fact that there's a big nuclear fleet and they're not so flexible to run. But once you go into the blue-gray, there's a lot of caution on what is the motivation to go this direction. If the motivation is to have CO2 to pump more gas, because you can use CO2 in gas wells, then we're actually extending the life of fossil fuel. And that's the opposite of our mission statement. So there is a potential risk as well that, especially in the research space, it's very important to be aware of where's the incentive or the motivation coming from to go to hydrogen.
And just if I may add some comment about why now, I think it's also because now we have a momentum, for our renewables and hydrogen, and this was maybe not so true 10 years ago. We are speaking about energy transition for a while now, but I think that generally speaking, now public, private, research and broader audience in general are more aware of the climate changes, the past crisis that we just had. COVID pandemic, then war and everything around the energy crisis made everyone more aware also of the stakes that are what's on stake right now. And the public investment is really high on hydrogen, both in France and Australia. I think in Australia, the federal government has already invested $1.6 billion. As I said, France will invest €9 billion by 2030. So public investment to fill out the gap between technology and market, private investment and private group that were traditionally more oriented toward oil or gas. If you think about Australia, you have a lot of resources, of course, in oil and gas. But even those producers, they are now targeting, green hydrogen production project, which I think it's also a big incentive also for private investor to really believe something is happening, a change is coming. I'm thinking, about groups like Woodside. They would have maybe not be really keen on investing on those kind of projects 10 years ago. But now the demand, on the market is really on green hydrogen. Australia is aiming to export its hydrogen. So it's not only on the domestic consumption side. You have to look, the demand is for green hydrogen in Pacific Asia and Europe in general. So to address this demand, people are really really have to now make this technology happen. So I would say the momentum is here, and now we have to seize it. There are a lot of challenges, of course, because it's a very early stage market. So we'll see what happens when research institution, private sector and public sector combine efforts to make it happen.
I'm being signaled that we're out of time, but I might just ask one question to Mahnaz. You mentioned in your presentation that you went to France recently and met many researchers. I'm just wondering, if you have any views in terms of any learnings from France, which Australia could adopt, particularly on that safety component.
Yeah, now what I have seen in my recent delegation trip to France, so they have facilities for prototyping. They have very advanced labs and facilities for the safety, hydrogen safety investigation, and they are working also on standards regulation as well. As far as I know, France is a key contributor to the European Union's hydrogen strategy and R&D programs. And also here in Australia, the standards, Australia is also has been working with stakeholders across government, industry, as well as collaborating internationally to find opportunities for hydrogen. And in July 2020, Standards Australia adopted 8 international standards for hydrogen, which including all part of hydrogen production, storage, safety as well. So I think collaboration with French researchers and institutes on development of sensors, which I presented in the slides, as we have capability here to develop the materials, promising materials, and also the device fabrication and testing, and also working together on the standards and the regulation would be key.
Oh, that's great. That's great. I think we probably could have gone for another hour with this discussion, but I think we're out of time. So once again, I'd like to thank our guests and the panel speakers today, Francois, Mahnaz, Niels, and Prune, for those fascinating remarks. And as I think we're now going into lunch, so if anybody's got any additional questions, please feel free to grab one of us, and we can certainly have a further discussion. Thank you very much.